again. It means either the check valve is choked or there's big air bubble that is in the system. So when you prime again, you will get rid of the air bubble. Okay? And check for leaks. If the pressure is low, sometimes it tells you that something is leaking from the system. So open up the system and check whether any tubing is leaking. Okay? So these are the things that you can check for system maintenance. And always remember, right, different solvent will have different back pressure. So if you have different method, right, you use different organic solvent. You sometimes use ACN, you sometimes use methanol, or you sometimes will use acetone. Always remember, all these solvents, right, they have different viscosity. And because of that, they have different back pressure. You cannot use the back pressure of methanol to estimate the back pressure of ethanol because they are different. Okay, so this is the pressure of the different solvent. So bear this in mind when you monitor the solvent. So this is the viscosity of the different organic solvent. If you can see, right, the solvent with the highest number will have the highest viscosity. Okay, the solvent with the lower number will have a lower viscosity. So if you need to know how to change certain things, like if you want to, if you know that check valve is blocked and you want to know how to change the check valve, there is an online help guide on our website. It's under the service and support. Okay, there is a video, how-to video on the different system. You can check on the system that you are having and know how to change the check valve or the inline filter. Okay. So this is a how-to video that you can refer to know how to change certain parts on our system when you have a problem. This one you don't have to. So any questions about maintenance and daily routine run, startup and shutdown? Any questions? Just now you actually want to ask a question, right? You actually want to ask a question, right? I forgot what you want to. I stopped you just now.
Mom, I want to ask about wet prime and dry prime. What is the difference?
What's the difference between wet prime and dry prime? Good question. In our system, Alliance system, there's two functions: wet prime and dry prime. Wet prime is the prime that you will use when you run routine system, and you know that the system is flooded with solvent and the system is not dry out. Then you will do wet prime because with a dry system, it's much more difficult to deliver the solvent in. So that's why with dry prime, there's an additional step that you need to do is to unscrew the knot, the black knot on underneath the Alliance pump, and use a syringe to draw. Because dry prime, right, when the system is dry, is sometimes very difficult for it to draw the water into the system. So you need to help the pump a little bit by using a syringe to draw. So that is dry prime. But after drawing the air out from the system, you are supposed to close the knot and continue with wet prime. So that is the difference between wet prime and dry prime. Yeah. But in normal routine, you should be doing wet prime, not dry prime. Yeah. Unless you run dry the system completely dries out. Then you will do. But again, right, I will still recommend you to do wet prime first, because sometimes wet prime would work. You will be able to flood the system back with solvent again with wet prime. But if let's say you do wet prime and the system lines are still dry, that is when you need to do dry prime, because you will help the system a little bit by pulling it with a syringe, pulling the air out with a syringe. Okay? Does that answer your question?
Yes.
I want to ask different Hplc and Hplc. In Hplc, there is a two parts, LC and detector. Yes. And in Hplc, there is a three part: USM or pump, FDN, and detector. What's your recommend in the first put on switch on?
Oh, the power on. Yes. Okay.
Pump or detector first?
Okay, very good question. Yes, I didn't touch on just now the power sequence. I didn't touch on Hplc because Okay, so the Alliance have only two modules, the LC and the detector. So you just have to power on the LC first, then the detector. So for Hplc, again, right, you should power on the auto sampler. The reason why is because, right, the auto sampler has the switch box that's connected to the instrument. So you should power on the auto sampler, then the pump, then the detector. Okay, but it's still okay if you power on the pump, the auto sampler and the detector is also going to be fine. But by right, because the brain is on the auto sampler, you should power on the brain first, right? So you should power on the auto sampler and then the pump and then the detector.
The computer.
After that, then the computer. This is the way the Ethernet should be connected. Yeah. Oh no. So okay. Now there's two different type of connection. In Alliance, right, do you have IEEE for your Alliance system? Okay, if it's an IEEE, then you have to power the system first, then you connect the software. But if it's an Ethernet system, then you should, let me see, I got confused because it's a different powering sequence. Ethernet and IEEE. Ethernet should be powering on, no, so for Ethernet, okay, system with Ethernet, you should start and power first, then you power on the sequence. Okay?
Sometimes sometimes if we first switch on the application system, it's not connected with that.
Yeah. If sometimes when you switch on the application, it's not connected. One way you can do is just to reset communication. It's because the software is not connected to the system yet. Yeah. On Empower, there's a few box, right, for the different module for Hplc. You just right click reset communication. Yeah, and that should solve the problem.
Ada dua type connection, ada AAA, ada Ethernet.
Ya,
Kalau
dua type.
AAA itu instrumen dulu,
Ya.
baru nanti komputer. Kalau yang Ethernet itu komputer dulu, baru nanti sistem.
Yeah, we have the document to let you know the power on cycle. Okay. So these are the potential source of the problem for your chromatographic system, and namely it may come from your mobile phase, injector, inline filter columns, detector, sample, everything can contribute to the problem in the system. So for you guys, right, you need a very systematic and logical way of troubleshooting the problem. Okay, and this is what I'm going to brief you on. How can you logically troubleshoot a problem that you have in a chromatography? So first thing, you should simplify the troubleshooting process by separating it into two categories. Okay, one is mechanical failure and one is chemistry. The problem is related to chemistry. Okay, so how do you know whether it's mechanical or chemistry? Okay, so mechanical failure is sometimes due to the pump, the injector, poor connection. Okay, all these are considered mechanical failure. It has nothing to do with interaction of the molecule. But when it comes to chemistry, it can be due to that column, it can be due to the column chemistry, it can be due to the wrong pH on the mobile phase. It has, so for chemistry, it's the interaction between the analyte molecule and the column stationary phase. Okay, so how do you differentiate? First thing you should ask yourself, when you inspect the chromatograph, are you getting good peaks for all your peaks? Okay, all your peaks. If yes, that means you have a fantastic system and a good column. But the next question is, okay, is your peak affected? Is all your peak affected? Okay, you have 4 peaks. If all the peaks are affected, the answer will be yes, all the peaks are affected. Okay, if you have 4 peaks and only 1 peak has a problem, like failing, like split peak, then it will be no, not all the peaks are affected. So if all the peaks are affected, the likely cause will be classified either the system, the tubing, the connection, or the inline filter or the injector. Okay, there is only very limited chemical issue or chemistry issue that will affect only all the peaks. Okay, so but if within this 4 peak, only 1 peak is affected. It's likely due to chemistry. Okay, because the column has been overloaded. Okay, because there's co-elution and because there's some solenoid activity. Okay, so when you see this, okay, very common profile, right? When you see this, right, immediately you should suspect that this is a mechanical problem, which means, right, first thing you should check is the connection on your tubing, the connection from your system to your column and on the system itself, because any void on the system or the column will give you this kind of problem. Okay, so do you see this kind of problem very often? This is mostly due to mechanical fault. That means connection problem, or there's a void in the system. Is it common here?
Similar distortion. Itu peak pecah kan sih? Pecah.
Sometimes. So
Saking jeleknya
once
kalau-
you see this, right? You see all the peaks are splitted, right? That means there's some connection in your system that's not connected properly. That's why you see all the peaks that's split. But when you see one peak that is having a problem, a tailing, a splitting, then it tells you it is due to chemistry. Either the column is too old, either you prepare the wrong pH of your buffer, or there's something wrong with the chemistry of the analyte with the stationary phase. Okay, so this is an example where all the peaks looks good, but there's only one peak that have a distortion. So it's chemistry problem. So a very important term when we talk about chemistry problem is solenoid activity. So what is solenoid activity? Solenoid activity is the interaction between your analyte and the stationary phase anionic group. So the anionic group here is the O minus, the negative charge. Okay, oxygen. So when it's in a mobile phase pH lower than 3, all these solenoid group OH, they are actually protonated without a charge. Okay, but when you run any mobile phase pH above 3, like 4, 5, 6, 7, this starts to lose a H plus ion and becomes deprotonated with a negative charge. And this becomes a charged surface, and it will interact with your basic compound. Many of the basic drugs are basic compounds, and give you the tail that you see. So if you can see, right, in terms of chemistry, you will have basic compound that will be very sharp, but basic compound that will have very serious tailing. And sometimes it's because of the stationary phase. Sometimes it's because of the pH of the buffer. Okay, any questions here? So this is what we call solenoid activity. Just now one of the chemical problems, solenoid activity. So if you prepare the wrong pH, it will cause that tailing to be very serious. If you use the wrong column type, especially R&D, the original method was developed on this column, but use another type of column, you may see excessive tailing because it's the wrong column, even though they are both C and D column. Okay. So let's focus on mechanical problem one. So what is the cause of mechanical problem? So mechanical problem would sometimes cause a bend spring, distortion of the split peaks. Okay, and it's a combination of instrument and column influence. Both instrument and column will have this mechanical problem. So first thing first, instrument. Between instrument, do you know that there's a difference in different instrument that you have? So in this lab, how many types of Hplc do you have? Only Alliance? Do you have other brands of Hplc? No. How about UPLC? You only have UPLC, or you have other UPLC, 1290 or Shimazu, etc. Only UPLC. Okay. So for you, right, you just have to remember HPLC and UPLC, they have different band spread volume, and because they have different band spread volume, the peak width will be different when you run the same method, same column, same mobile phase on these two different systems. So there's a way to measure band spread. We call this parameters band spreading. Okay, some system has bigger band spread volume than other system. So there's a way to measure band spread. Okay, I'm not going into detail. Okay, and this is to measure how wide the peak has broadened. Okay, the wider the peak broaden, the bigger the band spread of the system. Okay, so what happens if you have band spread? Okay, one of the reasons for band spreading is also poor connection. When you have a poor connection and when you leave a void in between the connection, that void actually increases the band spread volume. Okay, and this is an example whereby, right, the connection is not well fitted, the column actually is not well fitted to the connection, and there's a void there. And when you have a void there, this is another picture, you can see there's a space there, and this space increases the band spread volume. Okay, and when you have a space there, it will cause your peak to broaden. Okay, compared to a column that is well fitted on the system. So another reason for band spread volume is the tubing. Okay, different system you will notice there's different tubing color. There's red color, brown color, or even black color. Do you know there's different ID on the tubing? Okay, so when you change a tubing on the system, always remember to change back to the same color and same length, because when the tubing is, the ID is too big, it will cause a band spread. Okay, narrow tubing, the volume is lower, so the band spreading volume is smaller, so you will have a nice sharp peak. But when you have a tubing with huge ID, you will have a band spread. Okay, so which means, right, if you use a tubing with big ID, right, previously when you are having peaks that's very close together, once this tubing is changing, you may have these two peaks co-eluting. Okay, sometimes it's not because of column problem, but because you use the wrong tubing on the system. Okay, so that's why when you replace a tubing, always remember it must be the same color, it must be the same ID, and it must be the same length. Because with longer tubing, the band spread volume is also bigger. So you will also have diffusion of the tubing. Diffusion of the peak. Any questions here? So this is an example. This is an example of a good chromatogram. But this customer, when they replace the tubing, they replace to a bigger ID tubing, a longer tubing. And this happens. The peak starts to broaden. And peaks that is well separated with a resolution of 2 now only have a resolution of 1. So they were still wondering, why am I having this problem? Is it because of the system? No, this is not because of the system, but because of the wrong tubing that's replaced on the system. Okay? What can I ask you? Do you change your tubing very often? The peak tubing, the tubing that is connecting your column to the detector. Do you change it very often? No. Okay. Actually, you should always check the tubing also, because every time you tighten, right, there is a chance that the tubing may be kinked. Kink means you will see a line on the tubing. That means it's forcefully constricted. You understand? That means the tubing, the hole has been constricted because over tightening. Yeah. And when you loosen and tighten too many times, sometimes it will start to have that constriction.
So,
and when you start to have that constriction, right, you will also have problem with your back pressure and separation. So you should always check your tubing. Once you see that it's constricted, once you see that there's a line there,
Hplc baru nggak ada murnya.
either cut the tubing or change to a new tubing. Yeah, a lot of customers did not realize that this will cause you to have a leaking or sometimes a broadening of the pig.
What is the good tubing in plastic or stainless?
There's no good tubing. Okay, tubing at different part of the system, you have to use different material. So for the part that has very high pressure or that is near the pump, we usually have stainless steel tubing. But for tubing that's going to the column, you can use both stainless steel and pig, no problem. But there's benefit for stainless steel tubing is that you can connect it tightly. Okay. But for pig, once you connect the nut, right, the tubing, the ferrule is fixed at the position. Okay, so if you want to use different brand of column, you have problem because different brand of column, the end connection, they have different depth. Just now you saw that, right? Different brand of column, this part is different, the end connector. So sometimes it's deeper, sometimes it's shallower. So if you have stainless steel nut like this, once this is screw tight, this part, the ferrule is fixed. The position is fixed. That means this is fixed. You cannot poke the tubing all the way to the end. Okay? So that's why when you use different brand of column, you may sometimes risk having a void there. Or you may even risk sometimes having a space here at the ferrule area. So stainless steel tubing will have this problem. Pig tubing, because it doesn't fix to the position, you can push it through and tighten. So you will minimize this chance of having this void with different brand of column. So that's why there's advantages of pig tubing and stainless steel tubing. So it depends on customer. For Alliance, we have pig tubing because we know customer want the flexibility to use with different column. So that will be good for using with different brands of column. Any questions? But the problem with pig tubing is because it's pig material, you hand tight. Sometimes when the pressure is too high, the tubing will start to shoot out. That is because the pressure shoots to a level whereby the pig tubing cannot hold it anymore. Okay, so the pressure resistance of the pig tubing is not as high as the stainless steel tubing. Okay, so that is something that we have to balance: a pig tubing and the stainless steel tubing. Okay, but for HPLC method, the pressure, the pig tubing should be able to withstand the pressure of the HPLC system or the HPLC column. And so this is so another reason is because where you have a void is from the column. This is a well-packed column. When you usually if you have a column, right, you don't take out the column nut and see, right? But if you take out the column nut, you will see that the packing is actually at the brim, to the brim. Okay, this is a well-packed column, and a well-packed column will give you very nice sharp pick. But when the column starts to collapse, then you will see a void. And this is the same thing that you will see that if there's a tubing, there's a void, and the column when there's a void, the same thing, it will start to rent spread. It will start to split. Okay, so this is what happened when that column collapsed. Okay, and this is mechanical fault because it happens to all the pigs. You can see that all the pigs has the same problem because it's the column, the physical property of the column that is changed. Okay, so the reason why the column collapsed is because first, too high. The pressure that you use on this column is too high. Most of the column, we will tell you what is the maximum pressure that you should use on this column. Never go above that pressure because it will collapse the column. The pressure is too high. Second, the wrong pH. Some column, it cannot withstand high pH. If you run this column with high pH, the powder will be dissociated and it will come out from the column into your mobile phase. And that is where the material will collapse. Okay, so wrong pH, wrong pressure. So always check your column can use manual for the correct pH to use, for the correct pressure to use. Okay. And sometimes when the column is blocked, it may not be blocked completely. When the column is blocked completely, it's easy for you to know because the pressure goes up very high. But sometimes the column may be blocked partially. Then the pressure may only increase by maybe 1000 psi. Okay? But when you have a partially blocked column, you will also have distortion of the peak. Because the band, by right, is supposed to be a very nice sample band when the sample injector injects. But when you try to squeeze into the column, which is partially blocked, it will distort the band and cause you to have the poor peak shape. Okay? Any questions? So, let's come to the column flushing procedure. What should you do if you find that the column is blocked? Okay? So, when you start to see that the peak shape starts to change, you get poor peak shape from your column, and when you see that the back pressure is increased, you have to suspect that the column may be blocked or contaminated. Okay? And the first thing that you should do is to start to flush your column. You can do flushing in the same direction, or you could do a back flush. What I mean by back flush is you reverse the column orientation. Okay? And one of the solvent that you can take to aggressively clean or regenerate your column or to flush your column and is this solvent. Okay? Water, methanol, PHF, methanol, water, and mobile phase. Each solvent 20 column volume. And you should be doing this in sequence. It should be water, then methanol, then THF, then to water, then to methanol, then to water, then to buffer. Okay, this should be the sequence. So if you find that your column is blocked and you want to regenerate your column, this is what you can do. You reverse the column and you flush with all this solvent. Okay, any questions? So for column storage, how should you store your column? A lot of customers also ask us this. So for column that you are going to use it every day, you can store it in mobile phase, no problem. Okay? But ideally, right, if it's in high salt buffer, okay, you should flush it out and keep it in water methanol. Okay? So storage for short period of time, less than 3 days, yes, you can store it in mobile phase. But if you're going to store it in longer time, like 1 week or 1 month, this column should be stored in shipping solvent. What we mean by shipping solvent is the solvent that we pack this column and ship it to you. So this is a shipping solvent. For water's column, C18, it will be in ACN. So we recommend you to store water's column, if you want to store it for a long period of time, in ACN, 100% ACN. Okay? Any questions? And the reason we don't say anything for solvent is because, right, different column manufacturer, they may have different shipping solvent. So you should check with the column manufacturer what is the recommended storage condition. But I can safely tell you for waters, it's ACN. Okay? So for organic, for bonded phase, okay, for cyano column, for special chemistry, you may not be able to store it in organic solvent, then you may need to store it in water or buffer. Chemistry like cyano, they actually deteriorate very fast in ACN. So in this case, you may need to store it in water or buffer. That's why always look at the shipping solvent, because we will not ship the solvent, the column in a solvent that deteriorates the column very fast. So the shipping solvent should be the best solvent to store your column. Okay? So what should you do when you first receive the column? Okay? So first, as I mentioned, all water's reverse phase column are always shipped with 100% ACN. Okay? To use this column, first you must flush with 100% of ACN with 10 column volume. Okay? Flush out the ACN first. Okay? equilibrate the column with ACN first. Then, if you are going to mobile phase, if the mobile phase salt buffer is not too high, you can flush with, you can equilibrate with 10 column volume of mobile phase. But if you have very high salt buffer in your mobile phase, always go through water first. Okay, water ACN, 5 column volume before you go into 100% buffer. You understand what I mean? Okay, so maybe if your buffer is 10 millimole of salt, then it's fine. The salt concentration is low. But if you have like 500 millimole of salt, when you first receive the new column, you should first flush it with ACN first. Okay, 10 column volume. Then you should flush it with 50 water, 50 ACN, 10 column volume. Then you go into your, then you go to 100% water. Okay, then you go to your buffer. Okay? Any questions? So the slides here says 5, but I recommend you to use 10 column volume, safer. Okay? So this is an example of any question now? So I've already gone through some of the column maintenance. Any questions? I think that is all that I want to talk about for column maintenance and system maintenance.
Oh yang bahasa Inggrisnya, kalau ada yang mau nerjemahin nggak apa-apa, gue tanya banyak dah.
Apa lu mau nanya apa?
Hah? Banyak banget. Cuma nggak bisa bahasa Inggris malu.
Kan lewat itu.
Hah?
Ada baca cocok.
Lo mau nanya apa?
I want to ask about the impurity, Mom. I'm saying, Mom, my English is bad. English banget. About apa deh? Kemarin deh.
Purity.
Yeah, the noise is very bad because my Hplc is not not UV. Meter is in Hplc, PDA. I don't have a choice. So I
you have a PDA, not a UV detector.
UV is in my friend. I can use that.
UV is not my friend.
Oh ya gitu deh.
Indonesia aja dulu.
Indonesia. Jadi apa namanya?
Kemarin gue jadi politik.
Prioritas pakai PDA udah di smoothing tetap aja jelek. Ada trik lain nggak dipaksain smoothing biar pakai PDA bisa aja? Gimana caranya tuh? Ini geradagan, udah di smoothing nggak bisa.
Noise-nya lebih gitu.
Kita pakai UV bagus. Iya.
Oke UV baseline-nya cakep.
Very nice. Okay. Can I ask you when you use PDA, right? What is the you are using water's PDA?